at one that looks like this, where it starts out and it gives you, oh, what angle is that? A right angle. What should you draw? Yeah, draw a right triangle. So many of you guys are just drawing the regular 3-second flaws. 3-sided triangles, yes. Bless you. All right. When you see this, draw the right triangle. Throw it in there. You know that's got to be C. A and B doesn't matter. Okay. Little a is across from here. Little b is across from here. I believe on the skill check I gave you angle B as the 90-degree angle. It doesn't matter what the A, B's, and C's are. So let's just make this crazy. Call this B. Call this C. So we'll say this is B, and we'll say this is C. Okay. Isn't the hypotenuse still across from the 90-degree angle? Always is. Too many of you guys were taking it literally A, B, and C for Pythagorean theorem. You're right, wasn't it? Okay. So you got to draw the picture to set it up correctly to get the right value. So the right value on the skill check, I believe, for one of those, both of them were triples. One was an 8, 15, 17. The other one was 10, 24, 26. So you just had to do that. You got to use Pythagorean theorem to make it work. Okay. Here, same idea. I'd have to use Pythagorean theorem. So I get 121 and 16. 121 and 16 gives me 137, which I know will not simplify. So I know that would be there. Okay. When I do sine and cosine then, if I went back and I realized that this was C and this was B, I'm always going to reuse my givens. My givens were my sides. Don't use your hypotenuse. What happens if your hypotenuse was wrong? Will your angles be correct? No. So use your givens, circle, draw, opposite adjacent tangent, so it's inverse tangent, 11 over 4 will give you angle B. Do the same thing with A. Again, opposite adjacent inverse tangent of 4 over 11 will give you angle A. Okay. That's the scenario setups of what you would do for right triangles when you're given your two sides. If you're not given the two sides, if you have a side and hypotenuse, then you would have used, sine or cosine depending upon what information or where you were at. Remember, it's all about perspective. Okay. And that's kind of the biggest mistake that I saw on there. Other than that, a lot of science you guys are doing fine. I think it might have been just a typing error here or there. I think somebody, I didn't realize when I wrote this one up and I made the problem up, that I used 11 and 111. I think there were two people that wrote the angle as 11 with a side of 11, but they did everything right, and it just worked out. There's nothing wrong with that. Yes, ma'am? You can, just because you're doing sine, your sine of 90 is 1, because it's your opposite, and your opposite and your hypotenuse is the same thing. Yes, sir. On the homework? Yeah. Sure. All right, let's take a look then. Do a couple of these because I want to get into some good old-fashioned fun stuff of word problems. How do we draw pictures? Excuse me. So 35 is giving you 3 sides, which means right off the bat you should know that you're going to have to use a lot of cosines. So you draw your triangle, label it. Little a, 48, little b, 51, little c, 36. What angle do you have to find first? B. Yep, always find the biggest angle first, okay? Always find the largest angle, so we know that the b squared, the 51 squared, will equal 36 squared plus 48 squared minus 2 times 36 times 48 times the cosine of b. All right? And this is where we get into having to press a whole bunch of buttons. Remember, this really is nothing more than a 2-step algebra problem. If you want to break them into smaller chunks, go for it. It's easier to work itself through. So what I would do right off the bat is I would do 51 squared, I would subtract 36 squared, subtract 48 squared, and hit enter. And on my left-hand side, I get negative 999 equals, well, on this side, it's going to be negative 2 times 36 times 48, negative 3,456 cosine of b. It's times the cosine of b, so what do you have to do? Divide, not inverse it, I can't inverse it yet. So I have to divide the negative 999 divided by the negative 3456, that's convenient. And I get some decimal. That crummy decimal equals the cosine of b. inverse cosine of my answer, and I get 73.2. When I round to 2 decimal places, bless you. I got 198, so that's going to be 73.2. Okay? Now, biggest mistake people will make when they're talking about law of cosines, law of sines stuff, you do so many things with law of sines, you do so much with law of cosines, you probably, at one point in time, you might accidentally hit sine when you're doing cosine. So be sure that you hit cosine on the calculator. Okay? So now you have the angle 73.2. Use that to solve for the other two angles using the law of sines. So sine 73.2 is 251. Sine of A is 248. All you gotta do is multiply by the 48. So I get 48 sine 73.2. Enter, divided by 51. Enter second sine of my answer, 64.29. And then lastly, do it one more time. Sine 73.2 is 251. Sine of C is 236. Again, now I just have to multiply by 36. Sine 73.2 divided by 51. Second sine of my answer, I get 4251. Some of you are probably asking, why didn't I just subtract it from 180? Well, not just that, but what if my angle A was wrong? What if it was? Yeah, I know when you get and anyway, I'm just saying. Well, all right, let's deflate our egos for a second, and let's just say that.
Can I inflate mine because mine's real?
If you must. Here's my thing. What if you did get it wrong? Then C would definitely be wrong. Always reuse what you're finding as you go through and try to do it that way. Okay? Does that make sense, sir? Yes, ma'am.
So you have to start with the biggest.
Yep.
Sign.
Always. That's the rule.
I started with the.
Yeah, always start with the largest. That's why we said that. It takes you away from having the possibility of anything else. Even though I told you you have to worry about mine. Okay. What else you got in there? Which one? 32? This one looks like you have to do law of cosines again, and you have to find A, and it goes real fast. This one should be quick. Shh, guys, come on. So you're going to get A squared is 17 squared plus 48 squared minus 2 times 17 times 48 cosine of 34. One thing I noticed yesterday in Flex was that people were writing down different parts of different problems when you did this one, so it's not the end of the world, you just got to be careful with it. So let's see, 17 squared, 48 squared minus 2 times 17 times 48 cosine 34. Second square root of my answer, I got 3521. And then you just go here. Yeah. Let's do some word problems. Yeah. Not if you start with cosines. Like I've been saying that all along. I will not make a check for ambiguous if you have to start with cosines. Oh, I forgot before I did that. So yeah, remember how we did that area formula, that sine angle sine area stuff? Yeah. So what's nice about that one was when you had a triangle, like that example here, we had that 34, 17, and a 48. We could find the area of that triangle by doing, what was it, 1/2, 17, 48, sine of 34. That would give us the area. Now, what happens if you've got, what was the example we had yesterday with the 3 sides? It was...
Sharp. The sharp one?
No, not the shark one, just when we did a cosine problem with 3 sides.
13, 8, 18.
13, 8, and what?
18.
18. So there's another formula that does something like this. It's called Heron's formula. And it's called, you have to find a, let me pull this up, where was it? Yeah, this thing. So what you have to do is you have to first of all figure out the semisphere of the actual triangle. Now, in order to find a semisphere of a triangle, you wind up doing this formula of 1/2 of the sum of the sides. So that one was what, 8, 17? Yeah, this is stupid. Use law of cosines, get the angle in between and use that. It is stupid.
This is silly.
It's silly. Ew. It's a giant U. Would you want to try and do that?
Well, I gotta find the S value and then subtract it from each of the side values, multiply it all together, and then take the square root. It's just not gonna be fun.
So that just sounds stupid. So, like I said, don't use Heron's formula. It's the dumbest thing ever made. What I would do here, what I would do for something like this, if you had to find the area given 3 sides, if this was A, B, and C, what angle would you find first? A. Just get the largest angle and use the side angle side formula of this. So you have to use law of cosines to get the angle, but it's so much faster than, yes sir, yep. Don't ever use that Heron formula. Don't ever look at it. Avert your eyes. Think of it as a scary movie scene. You don't want to. What's that? No premarital eye contact. That's just bad. Yeah, you just get the dry heaves. You know, nothing gets you out of bed faster than hearing a dog trying to puke. Ah, get her out of the house. I tried that, but I don't know. I can try and make voice the same design. I don't know. No, I don't know how it's gonna work. That was more of a Professor Freak thing from The Simpsons, but I was going with that voice. I can't call it back now. It's lost. It's gonna haunt you, right? What's that?
Release that.
All right. So, but one of the things that you guys will find out, especially next year, is that we use law of sines, law of cosines for word problems a lot in pre-calc. And what you're also going to wind up doing is you're going to wind up using what are called bearings. So bearings are how you navigate, and they're dependent upon if you're on a boat or you're in an airplane. The way the bearings work. So eventually you're going to have to know north, south, east, and west. I know it's tough.
Oh my God, I got it right now. That is north, south, west, northwest.
Chicago is this way.
Correct. Now, if you were drawing it on a piece of paper, does it matter?
No.
You just draw a little compass and go from there. Correct. We all know that north is always, if you were to draw, if you had to do so on paper, I would just say never eat soggy waffles.
Never ever smoke weed. That's the one I like to know.
Anyway. So the idea is, I might ask you, if you start somewhere and go due east, what direction would you draw a line? To the right, and so on. But that's besides the point. If I do have something like that, I would probably draw a little compass on the page so you don't forget, because whatever. But anyway, what I wanted to do today was kind of go through a couple of the styles of the word problems on here. You'll have to forgive me, I kind of cut and pasted off of some of the problems that I had. I did not have an original copy of this, all I had was my worked out key, so I had to kind of cut it all up and white it all out and hide answers and stuff, so you can go from there. Well, if you squint just right on some of the badly photocopied cards there, you're going to be okay. But, well, we'll be all right. So let's do this. Let's just start with number one and kind of see what it looks like. How do you draw it and go from there? Okay? So let's go and, what's that? Congrats. All right, so Juan and Romella are standing at the seashore 10 miles apart. He's yelling to Romella, "Oh, Romella, I love you so much, my darling." And she's yelling, "Oh, Juan, you're my best." But they can't hear each other. Right, but they can't hear each other because they're 10 miles away. So they're trying to figure out how are they going to meet up, I guess. I don't know. So the coastline is a straight line. Shh. FaceTime. Hold on, let's guys, come on. This is fun stuff when you get to draw pictures. So Juan and Romel, they're standing at the seashore 10 miles apart. So we have Juan.
Are they gonna run towards each other?
In slow-mo.
In the slow-mo? It's gonna take a long time.
Oh, yeah, of course.
We'll give her longer hair than Juan. Okay.
No, actually, that's the longer hair.
They are 10 miles apart. Now, the coastline is a straight line between them. Both can see the same ship in the water. So we need to draw a boat.
Like that.
It's sinking.
Thank you.
See the water?
Arecibo is a ship.
The water is going into
The angle between the coastline and the ship and Juan is 35 degrees. The angle between the coastline and the line between the ship and Romella is 45 degrees. How far is the ship from Juan? So we have to draw some imaginary line from Juan to the boat, and to Romella to the boat. What was this angle here?
35.
What's this angle here? What are you trying to solve for?
How far Juan is from the boat?
We're trying to find this. Okay. Now, if you look at this, you have angle, side, angle. Okay. So what we need to do is we have to use how many degrees in a triangle?
180.
So if I add 35 and 45 together, what do you get?
80.
How much is left at the bottom then? So we know that this angle here is going to be 100. Isn't this a law of sines problem then?
Yeah.
And then I need to use the 45 to here.
Wow.
So I have sine 100 is to 10, as sine 45 is 2x. Cross multiply and solve for x, and there you go. Okay? I'm assuming you guys all saw Forrest Gump, right? So number 4 will help remind you of that. So, Janet, it's the most beautiful name in the world. Janet. Yeah. That's awesome. That is great. So anyways, yes, I just thought it was funny. Janet. I don't know what that is. I'm not the rotten man, Janet. It's a great movie. Yeah. It's a really good movie. So real quick, let's flip over to the other side where it's kind of blotched out a little bit. I want to try and read over a couple pieces in case you can't see it. Yeah. Plane A is flying directly toward the airport, which is 20 miles away. The pilot knows plane B 45 degrees to her right. Airplane B is also flying directly towards the airport. Actually, I think I have the other copy of this here. So here it is written out cleaner. So it's just missing out on the side there. It says airplane A is flying directly. The next line should say airplane B 45 degrees to her right. The pilot of airplane B calculates the airplane A is 50 degrees to her left. Based on this information, how far is plane B from the airport? All right. So you might want to write that a little bit in, just so you can clear it out. And I'll talk about degrees and minutes. Yes, sir? Oh, whatever. All right. Again, this is nothing more than taking a look at the picture, some sort of perspective idea of what it looks like. You have to have how many airplanes? And a tower somewhere, right? So that's kind of what you're drawing. Again, as I envision this problem, because I'm nothing more than the world's greatest artist, I know. I got an airplane here.
Looks like
Those are the jets.
It's on fire.
So here's airplane A, and then we'll just make another one just like it. But we're change the color of it because why not?
Could you maybe flip it? Okay, I will.
Let's make it red real quick. So again, we have two airplanes. Well, there's one, and then airplane A is flying directly towards the airport, which is 20 miles away. So airport. Satellite dish and a flag. 20 miles away. So plane A. "45 degrees to her right," so airplane B is 45 degrees this way.
Dang, I tried to.
Well, it's gonna be a 45.
Does it? Yeah, you can't assume those things. I forgot to mention that.
Yeah, I know.
And then this airplane also has to go to the airport. To its left is 50 degrees. And then you go from there. Does that make more sense? What? They've done goofy.
How far is airplane B from the
Right. So think of airplanes to their right. To their left. You haven't drawn up the wrong spot. Okay. The other one on that sheet was a little also kind of messed up, was the one with the degrees. Now, one of the things on here, it talks about degrees and minutes. Okay? Degrees and minutes. It says it's an angle of depression of 17 degrees, 47 minutes. Now, that means we have to know how to convert that. If I'm not mistaken, 17 degrees, 47 minutes. I'm pretty sure where that button was here. So 17, I think it's under math. Which one is that? It's, oh, angle, second angle. There you go. All right, so if you hit 17, then it hits second angle, which is the apps button. Hit number 1 for degree. And then, what was it, 47 minutes? Then we go 47, second angle, 2 for minutes. Okay? Then, I forgot to put, if you had to type that in, that's how you type that in with, like, let's say I have to insert sign, I don't know. And it would do it for you, okay? Just remember, if you've got degrees and minutes, you have to put in the degrees and minutes. But the calculator has a button for it. Does that make sense? I just want to make sure you guys saw how to put that in. It was second angle. That's how you get to the degree symbol and the minute symbol. Okay, second angle, yes, sir.
So like when we find the, when we know where to put the angle of depression for 17 degrees, 47 minutes.
Yeah, yep, that's all it means. It's just, it's kind of like a decimal. The degrees, the minutes are 47 out of 60, and that's how we convert it out. So when you get into navigational stuff, that's when it starts to degrees, minutes, seconds. So if you ever look at latitude, longitude stuff, it's broke down via stuff like that. We don't really worry about that here. I just tell you there's a button. You'll do some conversion stuff next year. So again, obviously for this problem, a little bit is kind of splotched out, if you will, on the page. So if you want to read it here, it says flights 104 and 217 are both approaching O'Hare from directions directly opposite one another at an altitude of 2.5 miles. So that means they are horizontally across from one another. Okay? Their distance across from one another is 2.5. I'm sorry, the altitude is 2.5 miles. So they're up 2.5 on both sides. Okay? So we have a plane. I'm not even trying it anymore. So we have two planes. It does. The pilot of Flight 104 reports an angle of depression to the tower, and the other one has another one to the tower. So they're 2.5 miles apart. We got to put somewhere in here in the tower. No, I meant altitude. I'm sorry, the altitude is 2.5. Excuse me. So we have the angle of depression to the tower here was that we'll call the 104 is this guy. And the other one is the 217. So you have your angle of depression here at that 17 degrees, 47 minutes. This guy has the angle of depression at 12:39. You're trying to figure out how far apart the two planes are. What is this thing drawing? What is this thing making for you? Big right angles. How many right triangles is it making? Two of them. Okay, I'll leave it at that. The rest of this should be relatively straightforward. There's not a lot of super goofiness with these things. Go ahead and start working on this now. I did already post the solution thing with some of the pictures on there, so that way you can check your stuff as you're going through. Monday, when we get back, we'll kind of tie everything back together to check these things through. Tuesday, the first official quiz thingy-majiggy for the trig stuff is all everything with calculator. So it goes back to right triangle trig, law of sines, law of cosines, ambiguous case if needed, elevation, depression, and then these types of problems. Okay. Tuesday. Okay. Should be relatively straightforward. I know you guys can do the law of sines, law of cosines, so not too much of a hassle. These picture ones aren't terrible as you get into drawing them. Remember, on your sheet for these degrees and minutes, make sure you put second angle. That way you know where it's at. You go from there. That way you can know what buttons to press. then that means on Wednesday next week, we put it down with our calculators probably till after spring break. That's about right. Five Mondays. Yeah, you really
Nobody asked.
But you can leave now if you want.
Yeah.
I mean, where are you going? Where are you going? Where are you going?
I am going south.
Okay,
That's just a direction.
why don't you just start walking now? Your parents pick you up.
Well, it's you. I'm gonna have to.
Well, they can just throw the car and meet you there.
This is gonna have
Yeah, that same thing where I can say, I can give you like a fraction, what is the secant? You know, if the cosine is something, it says what is the tangent. So, and that's just that right triangle stuff. So, oh, Raylan, it's too easy sometimes.
What?
Make fun of it. Yes, ma'am. Now, if you have all the angle stuff, are you putting in your Yes, ma'am.
So, Monday is gonna be like
I hope.
is there gonna be like degree things like this?
That's my kind of use
So, I know on the quiz.
That could be. Absolutely. It's just honestly, if you get into it, it's just another button press.
Do you put when you're like figuring it out? Do you put side in front of it?
It depends if you have any. I'm just saying if you ever had some sort of trick function, it would just be. I mean, you can type it in first and then go back to the trick function.
That's how much like that's the angle is 17
Degrees and
47.
47 minutes.
It was the
That's just, it's more precise than just 17 degrees. It's like 17 and a half. If you think of it that way. Now, when you deal with minutes, it's 47 over 60 would be the fractional amount.
so that's like
It's just how it's written.
Like 1
You can do that or you just use this is the question. Like breaking that. Those are
That's
possible.
oh, you're so dumb.
That's the idea. Just trying to see what you guys got.
My mom, she was doing I know, but they're doing like this with it. It's like the picture like the
I've seen that. I've seen those lessons like that before,
and
where you jump and you.
she was like, they think they want to like go. I said, I would want to go. Really?
Wait, what? What's the one? We didn't learn that until college.
You learn it in middle school. You learn angle-pair relationships way back when. Yeah. I don't either. I remember riding my bike to it. It was like 7 miles away from my house.
I've been down for a walk when I sold the high school. And my German teacher almost I mean,
Watch out for those crazy Germans.
I was like, I was crossing the street and like someone's moving forward.